Hello, in today's video we will learn about Redstone Bridge principle, its application, and as you have studied Kirchhoff's laws in the previous videos of current electricity, we will use that laws to derive the balanced condition of Redstone Bridge. So if you remember Kirchhoff laws, then it's good. Otherwise, firstly, revise the Kirchhoff laws first and then you can derive. So, let's start with the Redstone Bridge. It is an arrangement of four resistance used to determine one of these resistances quickly and accurately in terms of the remaining three resistances. As shown in the figure, which is an arrangement of resistors, is known as Redstone Bridge. You can see that it consists of four resistances P, Q, R and S in the form of a bridge and a galvanometer and a battery of EMF E. If the galvanometer doesn't show any deflection, that means the Redstone bridge is balanced. In that condition, means no current is flowing through the galvanometer, and you know that current flows from high potential to lower. If no current is flowing, that means the potential VB must be equals to VD. Now we will derive this condition. Again, consider the same diagram from the battery of EMF E. Current I is flowing. At point A, current I is divided into two parts, I1 and rest of the current I minus I1 is flowing through resistance R, through galvanometer Ig, through Q it is I minus Ig, and from D to C means through resistance S it is I2 plus Ig, and again at point C it will be I1 minus Ig plus I2 plus Ig, means again you got I1 plus I2 equals to I. At point A and at point C I have applied Kirchhoff's first law. Now apply Kirchhoff loop rule for loop A, B, D, A and you will get equation 1. Similarly, now apply for loop B, C, D, B and you will get equation 2. When the galvanometer shows no current, means bridge is balanced. So, by putting the value of Ig equals to 0 in equation 1 and 2, you got equation 3 and 4. And from equations 3 and 4, we got P by Q equals to R by S. Equation P by Q equals to R by S gives the condition for the balanced Redstone bridge, and if the ratio of the resistance R is known, then the unknown resistance S can be easily calculated by using the equation P by Q equals to R by S. Now, one main point you have to note that Redstone bridge is balanced even you change the position of cell and galvanometer. And the sensitivity of the bridge depends on the relative magnitudes of the resistance in the forearm of the bridge is maximum for same order of four resistances. Let's solve a numerical problem. It's an NCERT problem, and in this the Redstone Bridge is shown and the values of resistances are given, and a galvanometer of 15 ohm resistance is connected across this BD arm, and you have to find out the current through the galvanometer when a potential difference of 10 volt is maintained across AC. You can solve this numerical problem by using Kirchhoff laws, and we have three loops in this. By applying Kirchhoff law to the loop BADB first and then to the BCDB, and for the loop ADCEA, you will get three equations, and by solving these three equations you can find out the value of current as 4.87 milliampere. Now let's study about the meter bridge, which is also known as slide wire bridge. Meter bridge is the simplest practical application of Redstone Bridge that is used to measure an unknown resistance. That means it is based on the principle of Redstone Bridge, and when the bridge is balanced, P by Q is equals to R by S. Figure shows the systematic diagram of a meter bridge. AC is AB is a 1 meter long wire made of manganese or tungsten having uniform area of cross section, and this wire is stretched along a scale on a wooden base, and ends A and B of the wire are screwed to two L-shaped copper strips as shown, and a resistance box R is connected and an unknown resistance S is connected. Unknown resistance X is connected as shown. One terminal of galvanometer is connected to the point D as shown in the diagram, and another terminal is joined to a jockey that can be slided on a bridge wire. Now, when the galvanometer current is made zero by adjusting jockey position on the meter bridge wire for the given values of known and unknown resistances, then by using the balanced condition, you get R by X equals to RAJ upon RJB, and that will give you R by X equals to AJ upon JB, and that means R by X equals to L upon 100 minus L. Here, the resistance of the portion RAJ you can calculate by using the formula R is equals to rho L by A, and similarly RJB equals to rho into 100 minus L upon A. Here, the resistivity rho is of the material of the wire AB, and the portion AJ is of the length L, and JB is of 100 minus L. Therefore, you got X value, and that comes out to be R into 100 minus L divided by L. Let's solve a numerical. As shown in the diagram of the meter bridge, the null point is found at a distance of 33.7 centimeter from A, And you have to find out the values of R and S. Try to solve this by using the Redstone Bridge balanced condition. And for the first balance point, you got R by S equals to 33.7 upon 66.3. And when the S is connected in parallel, again use the Redstone Bridge condition and find out the new equation. And by using these two, you can find out the value of S equals to 13.5. And using the value of R by S, you got R is equals to 6.6. Now, the next question. Arrangement of the meter bridge is shown to you and you have to tell that what will be the value of AC if the radius of the wire AB is doubled. Answer is, as the radius of the wire is changed, so it will not affect the ratio of the resistance of two arms. So the value will remain the same, that is equals to X.